discuss the question now?
Yes, sir.
How many of you were able to come to the statistic?
Sir, I guess I could.
क्या है इसका टेस्ट स्टैटिस्टिक?
So beta 2, B2 plus B3 minus 1 upon root over of variance of B2 plus B3.
Yeah.
Sir, I have a doubt here. What about the Q? Will it be in the numerator divide by 2?
आयुषी, तुम्हारा आवाज ब्रेक हो गया. Could you come again, please?
Sir, did you hear the test statistic that I gave you?
Yeah, yeah, उसमें doubt portion नहीं सुनाई दिया.
Sir, the degrees of freedom in the numerator, which is Q,
Yeah.
will it be in the numerator divide by 2?
So उसका न्यूमरेटर क्या होना चाहिए? आप ये गेस करो पहले.
Pardon, sir?
Numerator will still be 1, no? Because there is only one row ना, dear.
Yes, sir.
है ना? तो न्यूमरेटर का f में it will still be 1 और denominator it will be still n minus k.
Okay, got it, sir.
है ना? Bhushan, you also raised your hand. Did you get the same statistic?
Yes sir, but I did not get how. आपने अभी बताया कि न्यूमरेटर में 1 रहेगा डिग्री ऑफ फ्रीडम, तो वो समझा नहीं.
क्योंकि q तो 1 ही है ना डियर. न्यूमरेटर का डिग्री ऑफ फ्रीडम इज q, नो? So I have only so जो डायमेंशन है r का q by k, that q stands for one row, right?
या.
So न्यूमरेटर का डिग्री ऑफ फ्रीडम तो 1 ही रहेगा.
अच्छा, ओके.
समझ में आई?
जी सर.
नहीं आया तो आई विल रिपीट इट अगेन.
सर प्लीज रिपीट.
जब आप q by k जो हमने q न्यूमरेटर देखा है, वो q किसके लिए स्टैंड करता है? That q stands for the dimension of r.
Yes sir, and it's
right?
1. Yeah.
है ना? r का डायमेंशन क्या है? 1 times वो जो नंबर ऑफ एक्सपेरिमेंटल वेरिएबल्स है.
हाँ.
And that's why numerator will have a degree of freedom given by q, that is 1.
Yes sir, got it.
What about others? Is there anyone else?
सर.
हाँ जी.
सर मेरा वो वेरिएंस B2 plus B3 तक आया है.
अच्छा.
उसके बाद में जो कन्वर्ट करना है जो स्टैटिस्टिक्स में, वो नहीं मुझे समझ में आ रहा. तो सर आप प्लीज.
कोई बात नहीं, I'll solve this, no issue. I'm just asking किन्होंने किया है.
Okay sir.
Manna, did you solve?
Yes sir, I got the answer.
Okay. What about Setu? Setu, were you able to solve?
No sir.
No issue. What about Naveen?
I have tried, sir, but not able to solve. So only able to know that this type of hypothesis is used in Cobb-Douglas production function, only else.
Okay. What about you, Ali? Were you able to solve there? Ali Asgar, are you there on the call? Okay. What about you, Pragati?
Sir, couldn't get it complete.
You tried, but you could not get, right? Okay. What about Gaurav? Were you able to solve? Gaurav, are you there on the call? Okay, all right. I'll solve the question and just let me know अगर कहीं पे भी आपको problem हो. So now, and you see the purpose is अब कैसा भी कितना भी complex hypothesis है आप you can easily solve them by solving this expression. That's what the purpose of this whole exercise is. So now my question is that I have a population regression function which is given by this beta 1 plus beta 2 plus beta 3 error term, and I have to test the hypothesis that beta 2 plus beta 3 is equal to 1. It can be anything. Beta 2 plus beta 3 is equal to 100, 200, 1 by 2, 1 by 3, anything. So this is my hypothesis that I have to test, and this is the statistic that I have in front of me. So first of all, मुझे क्या देखना है? I have to talk about this RB minus R. So if you follow closely, what will I get from RB minus R? मेरा B क्या है? मेरा B is B1, B2, B3. So I know that R जो होगा, it will consist of 3 columns and 1 row because I have only one simple hypothesis, and which I have to prove beta 2 plus beta 3 is equal to 1. It means here I'll have minus 1 because R stands for 1. B1 is not in the hypothesis, so here I'll have 0. For the place of B2, I'll have 1. For the place of B3, I'll have 1. So B1 plus B2, B1 into 0 plus B2 into 1 plus B3 into 1 minus 1 is exactly what I get, beta 2 plus beta 3 minus 1. So RB minus R say I'll get B1, sorry, B2 plus B3 minus 1. Now I have to look for the term R S square X transpose X inverse R transpose इसका inverse. अब I'll proceed in the same line. X transpose X को मैं simple पहले expand कर लेता हूँ, thinking that all the diagonal elements will give me the variances of the OLS estimators, and off diagonal elements will give me the covariance of the OLS estimators. So again proceeding like that, C11, C12, C13. Multiplied by S square. Now this gets multiplied by R, which is 0, 1, 1. And this gets post multiplied by R transpose, which will be 0, 1, 1. अब जब आप इसको expand करोगे तो क्या आएगा आपका first row first column, so C11 times 0 plus C21 times 1 plus C31 times 1. So first term will be C21 plus C31. C21 plus C31. Second term, yeah, again C12 times 0 will be 0. C23 plus C33. This is the matrix multiplication of R transpose multiplied by this X transpose X. This again getting multiplied by 0, 1, 1. So I'll have only term left with C22 plus C32 plus C23 plus C33. So I'll get C22 plus C32 plus C23 plus C33. Now you understand that this multiplied by S square, which is here. So S square times C22 is variance of B2. और ये term है covariance का, which are same because they're symmetric matrix. So this I can write it as twice of C32. So twice of S square times C32 is twice of covariance of B3 B2 plus S square times C33 is variance of B3. So I can write this whole expression as variance of B2 plus twice of covariance B2 B3 plus variance of B3, which is nothing but equal to variance of B2 plus B3. अब ऊपर में मेरे पास क्या है इन द न्यूमरेटर, और इस सारे का इनवर्स, because ultimately I am talking about finding the expression of this whole term. So इस सारे का inverse, it can be written in the denominator. RB minus R, say I got B2 plus B3 minus 1. This get multiplied by again RB minus R, which is again B2 plus B3 minus 1. So iska square. So I can write the F statistic as B2 plus B3 minus 1 ka square upon variance of B2 plus B3. और इसका जब मैं square root करूंगा, it will give me a T ratio. The T ratio of this will be B2 plus B3 minus 1 upon standard error of B2 plus B3, and this will be T distribution with degree of freedom given as n minus k. Now you just expand this linear hypothesis as long as you want. कोई भी आप यहाँ पे कुछ भी रख सकते हो. इसी तरह simply you can test whether B2 is equal to whether beta 2 is equal to beta 3 or not. In that case, what will happen? My null hypothesis will become B2 minus B3 is equal to 0. So ultimately, all these null hypotheses, they are basically giving different elements to the matrix given by capital R and the vector given by small r. So depending on which type of linear hypothesis you are talking about, उसी हिसाब से आपका R, कैपिटल R और स्मॉल r का एलिमेंट्स चेंज होगा. जो बीच वाला टर्म है, दैट इज s squared multiplied by x transpose x inverse, that will always give you the variance covariance matrix of the Euler's coefficients. And on the basis of these expressions, we are able to compute a statistic, which is a F statistic. Now, the usual procedure in such case of hypothesis testing is that the values that we calculate using such statistic, they are called as calculated value. And then depending on the parameter, that is degree of freedom, we compute the critical values from the F table or T table. And then we compare whether the F calculated is greater than F critical or not. If calculated value of the F statistic or T statistic is greater than the critical value from the table, you tend to reject the null hypothesis. इसका मतलब क्या है? Rejection of null hypothesis means कि जो vector है मेरा R B minus R, it tells me the discrepancy between the actual and expected observation, and this difference is just not only attributable to the errors of sampling. That is, there is a difference, and that difference is statistically significant. And that's why when you reject the null hypothesis, you say that T ratios or F ratios are statistically significant, meaning which that the discrepancy between actual observation and estimated observation is quite large, and that discrepancy cannot be attributed to errors of sampling. And this is what you should understand by statistically significant term. And when the F calculated or T calculated, that is calculated ratio, is less than the critical ratio, it means what? It means that the whatever difference that you have as far as the discrepancy between the actual and estimated observations are concerned, that discrepancy can be just attributed to errors of sampling. Meaning which जो भी difference इनमें exist करता है वो insignificant है. Why insignificant? Because since we are trying to draw an inference about the population using sample, and the moment we are talking about sample, there is errors related to sampling procedures, and it is due to such errors of sampling that we notice a discrepancy between the actual observation and expected observation. And hence we say that the T ratio or F ratio is statistically insignificant. So statistical significance and insignificance is associated with the idea whether the discrepancy vector is attributed to chance of errors of sampling or not. If it can be attributed to errors of sampling, the discrepancy is insignificant. That's why you say statistically insignificant T ratio. If it is, or if it cannot be attributed to errors of sampling, it means the discrepancy is there, and that discrepancy cannot just be attributed to errors of sampling, and that's why it is statistically significant. Am I clear with this terminologies related to hypothesis testing?
Yes, sir.
ठीक है, तो ये बात हमेशा याद रखिएगा, और ये इंटरव्यूज में काफी पूछते हैं। दो चीज आपको याद रखना है कि you never accept null hypothesis, you always reject it or do not reject it. Follows a rule that if computed statistic is greater than the critical value from the table, you reject the null hypothesis. And if the computed value is less than the critical value from the table, you do not reject the null hypothesis. अब रिजेक्शन ऑफ नल हाइपोथेसिस एंड नॉट रिजेक्शन ऑफ नल हाइपोथेसिस क्या है? रिजेक्शन ऑफ नल हाइपोथेसिस मींस the statistically significant difference exists between the actual and expected, and which cannot be just attributed to errors of sampling. And insignificant means, or non-rejection of null hypothesis means क्या कि जो discrepancy है आर बीटा और आर में, वो डिस्क्रिपेंसी ऐसा है जिसको सिर्फ आप एरर्स ऑफ सैंपलिंग पे आप एट्रीब्यूट कर सकते हो, and that's why you do not reject the null hypothesis. And why we always say that we reject the null hypothesis or do not reject it? Because whichever test statistic we use, we always start with the assumption that null hypothesis is true. और एक बहुत बड़ा फैलेसी है इन द माइंड ऑफ रिसर्चर्स, जिसके कारण बहुत ही ऑब्सक्योर रिसर्च भी कैरी आउट किया है लोगों ने, दैट एज अ रिसर्चर वी ऑलवेज टेंड टू रिजेक्ट आवर नल हाइपोथेसिस, and the moment we are not able to reject our null hypothesis, we start thinking that there is some problem with the research. As a tutor or as a researcher, I can tell you that this idea of hypothesis testing is absolutely, it should not be there in your mind. You always start with your null hypothesis, assuming something about, the population. If it comes, well and good. If it does not come, it does not mean that that result is insignificant. So even if you get insignificant T ratio, or even if you're not able to reject the null hypothesis, it does not mean that your research question is wrong. So, और ये इंटरव्यूज में बहुत ज्यादा पूछे जाते हैं कि स्टैटिस्टिकली सिग्निफिकेंट टी रेशियो का क्या मतलब है, टी रेशियो क्या है, so by now you must be able to answer that, what are the relationship between T, chi-square, F and normal, and that's why these tests are interrelated. You should be able to explain to anyone, or you should be able to solve any question which involves linear or simple linear hypothesis about population coefficients. Now, कैसा भी hypothesis दे दिया जाए आपको that beta 2 minus 1 by 3 beta through beta 3 plus beta 4 is equal to 0. You should be able to write or compute a statistic on your own. And solving this expression using this method, you'll never get confused no matter how complex the simple linear hypothesis is. You just have to remember the expression of the numerator, because denominator mostly is consist of the portion of variance covariance matrix of your OLS estimators. So whatever complexity that you'll find as far as questions related to hypothesis are concerned will only consist in the portion of RB minus R. So once you master कि क्या क्या elements big R में होने चाहिए, कितना रो, अब now if someone gives you a hypothesis that you have to solve or you have to test a hypothesis that beta 1 plus beta 2 is equal to 0 and beta 3 is equal to 1. Now this is an example of a compound hypothesis. Now the dimension of capital R will be 2, because you are testing two hypotheses at one point of time. So it's a combination of two simple hypotheses, and that's why your dimension of the order should be 2. So understanding this expression, please go back and revise whatever we have done today. Understanding this expression should not pose any problem as far as testing linear hypothesis about beta coefficient is concerned. And which is why I took up this through this method, because if I let you solve these hypothesis testing by simple calculating t ratio, whenever the question is is tweaked a bit, वहां पे प्रॉब्लम होने लगता है, वहां पे वी आर नॉट एबल टू फाइंड आउट कि अब मैं इसका टी स्टैटिस्टिक कैसे कंप्यूट करूं. और उसका एक सिंपल एग्जांपल ये बीटा 2 plus beta 3 is equal to 1 का था. So most of the time we tend to memorize the formulas, which we should not, or which we rather need not. So I give you homework for the same regression, for the same population regression function. For the same population regression function, you test two hypotheses. पहला hypothesis है आपका that combinedly beta 2 equals beta 3 is equal to 0. That is, you have to test whether combinedly both these regressors have any influence on y or not, and your null hypothesis is that they do not have any influence. And the second hypothesis जो आपको करना है वो है ये. So please find out the test statistic for these two coefficients. Let's say beta 2 को 1 कर दो और उससे 3 कर दो. Sorry. So you have to test these two hypotheses. They both are examples of compound hypothesis. आपको simple elements of R decide करना है, rest all the things will follow. You'll notice that when you have compound hypothesis, we do not have a choice of using either T or F. Whenever you face compound hypothesis, by compound hypothesis, I mean to talk about when you have the dimension of capital R more than 1. So when you have a compound hypothesis, you are only able to use F ratio or F statistic. And when you have a simple hypothesis, you have an option to choose between either using F statistic or T statistic by
So we lost your audio, sir.
T degree of freedom. Then squaring that T distribution will give you a F distribution having 1 degree of freedom in numerator and n minus k degree of freedom in denominator. So please solve these two hypotheses, at least compute the T statistic or F statistic for both these two hypotheses.
Sir?
Yeah.
No, it's fine, sir. It's fine.
Come again, Neil. आवाज तो बहुत clear
नहीं सर, कुछ नहीं.
Okay. So I'll stop here. Next two lectures, I think only Neil or two students have submitted their computer exercises. Obviously, this was not mandatory, so I'm not asking you to submit it compulsorily. But if you wish to solve those back-end computer exercises of Woolwich and submit it to me, well and good. Otherwise, I'll take up certain, data and we'll solve those exercises utilizing all the concepts that we have done so far on the software R. So we'll solve. We'll take one question. उसी में हम OLS estimators, hypothesis testing, various hypotheses की बात करेंगे, and then we move forward. So that is for the next two lectures. So अगर आप Woolwich का backend question कर चुके हो, and if you wish to submit, please do that. Otherwise, if you're confident enough, it's fine. So I'll stop here. If there's any question, please ask.
Sir.
Haji.
So for the TUT, is the syllabus the same, like till the 5th lecture or till today?
I don't know, Aishu. When is your TUT?
Sir, I guess next week.
Next week, we have much time enough. We have, I think, 2 lectures more. So mostly, you can think that आज हमने जितना cover किया, that will be the syllabus. Because anyway, in the next 2 class, I'll be solving the questions. So as far as syllabus is concerned, your assumptions of CLRM as OLS estimators, mean and variance of OLS estimators, inferences about the population parameters, that is hypothesis testing. So these are the 4 main or principal topics that will be the syllabus of your first periodical. Is that clear? I'll repeat it again. Assumptions of CLRM, OLS estimators, that is, the principle of least squares, mean and variance of OLS estimators, and hypothesis testing of or linear hypothesis about the population parameters. Is this clear?
Yes, sir.
Okay. And एक और रिक्वेस्ट है, आप अपने नेक्स्ट क्लास के पहले प्लीज डाउनलोड R for Windows, I think वर्जन 3.6 होगा शायद अभी, आई एम नॉट टू श्योर. सो कोई भी जो भी आपको लेटेस्ट मिले आप उसको डाउनलोड कर लीजिएगा, या R Studio जो भी आपको कंफर्टेबल. R Studio is actually better because it also gives you suggestions. So that will be a pre-requirement, and whatever question that will solve, I'll give you the data beforehand so that you can also try on your own before coming for the next session. So,
Sir,
okay, yeah.
could you please clarify a little on what kind of questions we could expect include? You just said like daily or ISA kind of questions, but a little clarification more.
And sir, would it be MCQ only?
MCQ देखते हैं कृति, अभी I have not set question, so let's see how do I set. And Himani, एक request है dear, why I sincerely don't encourage this is, मेरा मेन पॉइंट है कि आप कॉन्सेप्ट समझ जाओ, उसके बाद आपको कोई भी क्वेश्चन पूछता है, यू शुड बी एबल टू आंसर. और मेरे क्वेश्चन में 100 out of 100 लाके कुछ होना नहीं है. So itna I can assure you that whatever we have discussed in the class, I'll ask only those portions, and the paper will be fairly easy. So अगर आप क्लास में या अगर आप रिवाइज करते हो क्लास के बाद जाके, तो you should not bother at all. You'll be able to solve all the questions. But the main point is कि अगर आपको आगे कोई पूछता है, या when you face interviews next after your course gets over, so you should be able to probably solve at least 90% of the answers that will be my motive.
Sir, as far as references are concerned, would
हाँ जी,
Woolrich be enough or should we refer Gujarati as well?
वो आप पे डिपेंड करता है अली, आपको जिससे whichever book you are comfortable reading with, you can, but you should probably read Woolrich because Woolrich is a better book in my opinion. Otherwise, I'm not forcing you to read Woolrich compulsorily.
Okay, sure, sir.
है ना?
Thank you.
Ali, by the way, were you there on the call? I had called out your name.
Yeah, sir. Actually, some of the classmates also told me I must have had some kind of network issue or something, or I must have been away for a while. I won't lie to you, sir.
Okay, okay.
Sir,
हाँ जी.
for the tube, will we need to do it on R or pen paper?
देखते हैं आयुषी अभी. Let's see. पहले 2-3 क्वेश्चन सॉल्व कर लेते हैं, फिर if you are comfortable enough, then we'll have on R. Otherwise, I think Tute on R will be a bit difficult because it will be extremely examiners also to क्या बोलते हैं उसको coordinate. So mostly नहीं होगा, but I'll inform you on the day, second or third को.
Okay, sir. Thank you.
Yeah. Is that clear?
Yes, sir. Thank you so much.
Okay, okay. So, all right. Thank you so much for being in the class. I'm really sorry it extended to more than 2 hours. Just stay safe, take care of all others around you, and see you on Monday.
Thank you, sir.
Thank you, sir.
Yeah.